Hello, it's me, Mark the Physics Heretic. So from our last section, I started off with a discussion of what basically we need to understand and understand in a layered structure, or more importantly, the linear learning cycle. And I didn't display much of it. I just took us to something simple, a model of the helium atom. But even that wasn't massively complex on the subjects that have to be relearned. And that's part of the problem, is that today's modern physics brushes over so many core physics concepts that it eventually hides what you can learn from what's actually there. Now, in this short discussion, I'm going to go over the way I see particle structure. Please understand that the standard particle model and quark theory are basically garbage. Laughably garbage in many instances. I'm not saying that 3 quarks don't make up a proton. What I am saying is 3 quarks do not make up a neutron. I'm also saying that other components like pions, taus, the God particle, all that stuff is not what you think it is. More importantly, all the neutrinos and other subparticles aren't what you think they are either. I often read articles discussing neutrinos. For example, about 2 weeks ago I read this article where scientists are traveling towards the South Pole because at the South Pole there seems to be a stream of neutrinos moving through our planet. And those neutrinos are coming out the South Pole and they can't understand why. Reading that article made me laugh. You're right, you don't understand why. And you don't understand why is simple to understand from my perspective. You have no clue what a neutrino is. If you don't know what a neutrino is, you don't understand what it does, how it can interact with matter, or more importantly, not interact with matter, how it can behave, you really know nothing. So, before we go deeper into depth on that topic, I'm going to try to give you a basic understanding of how we're going to move through the topics in regards to matter. So, the first thing we want to do is to discuss matter individually. For example, our reference proton here, what it does standing still, what it does while moving, what affects it, what effect it has on other things. Specifically, all of its interactions without it being bound in any way to any other particle. Just the proton itself or the electron itself. I would spend time on the neutron itself, but it decays in 15 minutes. So we'll get to that at another time. Now, that would be this layer here. And the reason I'm choosing this large book to represent that is that piece of knowledge is the core Rosetta Stone to much of modern physics. The way that I see a moving proton compared to the way you see a moving proton lets me define how light photons are created. Complete physical process, complete breakdown of fields, where they come from, where they go to. Beyond that, I am able to fully derive relativity and even fix the errors that Einstein put into general and special relativity. I'm also able to take that information and, as per the previous lecture, describe how a proton captures an approaching electron and puts it in an orbital structure. Furthermore, I'm able to show other facets of its behavior. And that's just the interaction of a particle as it moves by things by itself. But that would be rather boring if that was just the case. So we're going to learn other things. The next thing we're going to learn is what happens when our electron and proton start to interact in a working system. That's the next section of the topic. And that layer of interaction is the case where the electrostatic force is the complete binding force, where the magnetic forces are small steering forces. They change the motion, they divert things, but they are not involved with the binding at all. But they're still required to make the system work. Now, after we exhaust much of what a hydrogen atom is doing by itself, we need to move further. And as I said in the previous discussion, is that we need to understand how nuclear physics occurs. Now, with nuclear physics, the whole concept and construct of how to build a neutron, how to build a neutrino, how to build any structure. In fact, you need to understand the basics of what a neutron is. You don't know. In fact, your theories state that what a neutron is cannot be, even after getting data that shows you otherwise. So we'll define what a neutron is. We'll use that to build nucleuses. And those nucleuses, we can build like Lego building blocks. We'll be able to show you why the carbon-12 nucleus is disc-shaped. Can't be spherical. We'll show you why that the oxygen-16 nucleus is actually a twisted cube, and is why it's the second magic nucleus, by going over the details of its structure that is extraordinarily strong. Furthermore, we'll use that same structure and remove protons to show why carbon-14 has 3 distinct structures, and those 3 different structures lead to 3 different decay paths, the most unstable of which is the reason that we cannot do carbon dating for the early years, which we should be able to fix after you understand it. Now, after getting to the nuclear structure and how that works, we will then go into high energy physics. See, with high energy physics, we're going to go into different types of structures. See, we said in atomic physics here that the Coulomb force is the only really binding force. In nuclear structure, the Coulomb force is the main attracting feature, but what keeps it from total collapse is an equal and balancing magnetic force that keeps those structures together. Now, what happens in high energy physics, the rules that govern nuclear physics are swapped. And in that case, please think of this as a red ball for a moment, is that the two protons actually are bound via magnetic forces through their spin and repulsed by the Coulomb force, which is another level of valid solution given the series of equations. And with that, I can build a complete model of the God particle. With electrons, I can build all 7 structures of tau, and there are 7. I can also, as it decays, cover the various components that it breaks down into, and the release of the neutrinos that are seen. But I'm also able to cover on how those neutrinos are formed and what implication those neutrinos have on the life cycle of any particle or nucleus. So with this layered structure in mind, we're going to be able to teach you much more about topics and explain their internal interactions. But at the same time, we will be pretty much destroying quark theory and the standard particle model. But my impression is by the time we get done with that, which is a long time from now, I think you'll be very thankful, because you'll be able to do all kinds of analysis and work of what you're seeing in the experiment and seeing where it really comes from. So, to recap, what we want to do is we want to build a layer upon layer discussion of how particles interact and take it through the what appears simple lone particles and take it through atomic, nuclear, and high energy structures. Now we need to do that because we haven't touched on things such as how 2 hydrogens form a covalent bond. We have that. We have the exact motion of the electrons and the exact behaviors. We have how a water molecule is formed, how the hydrogens attach to the open p orbitals, how those p orbitals go from a simple design to a quad design forced automatically by the stability of the structure and the ability that it has to not go into what is called precession motion, which we won't cover for several lectures yet. Also, once we have that, we can show the chemical difference between water and heavy water, where we were taught in high school that you don't have a chemical difference between 2 isotopes, usually. But with heavy water and water, you do. We'll show why that occurs. And with that, we'll be able to show why cold fusion actually exists. Because it'll be one of our first examples of how we tear down, or actually demonstrate, how to discover the quantum tunneling effect for certain interactions. We know how to do that. We know how to do fusion. That's right, fusion. We know how to do fission on the exact structure of what is happening. What to you is a black box where things going in and things coming out, we see it as an exact structure, motion, change, what bonds break, what bonds flex, all of it. But to get to those very valuable pieces of knowledge, you're going to have to take a long journey, a very long journey. you're going to have to rewrite your entire understanding of modern physics. And it's going to be annoying because you just spent your life learning what was considered the best, the current modern physics. But we're going to rip that to tatters. So, now, when we try to submit a couple papers, we were insulted by the journal by saying, you don't have the right credentials to file a paper. Namely, I'm not a PhD. In many of my submissions via Quora, many younger scientists have complained to me about, well, you're not a PhD. And they're right. I don't have a PhD. I only have a bachelor's. But the errors in physics that led to heretical physics are not topics and material covered in graduate level work of physics. It's actually the material covered in your introduction to modern physics. At the University of Arizona, where I went, the course was Physics 330, taught by Dr. Kohler. And Dr. Kohler, you did the right job in teaching that course. Because without understanding the history of it, I couldn't have done my work. But the errors in physics came there. Oh, there's some that came later. Some additional ones that added or multiplied by each other. But the basic first errors happened at the discovery of solving the problems from modern physics. So, we should probably get started. And on my next video lecture, let's discuss the behaviors of a particle as it moves through space and time. And what we see, what it sees, those kinds of things.